Good afternoon. Thanks for joining us across the fence. I'm Keith Silva, in for Fran Stoddard. Years ago, a farmer told me Vermont is one of two things. It's either a hill or a valley. Farmers know the lay of the land when it comes to soil and nutrients. Take phosphorus, for example. For a crop like corn, it means stronger stalks, better roots, and earlier maturity. But when it rains and that phosphorus washes off the field and into waterways, it means algae blooms, erosion, and decreased water quality. Farmers have been adjusting their practices, trying new ways to apply nutrients and make sure they stay put. The question is, do these practices work? And how well do they work when rainfall is more intense and less frequent due to climate change? The answer is a phrase we're familiar with nowadays: trust the science. To study rainfall and nutrient runoff, all you need to do is find someone who can bring the rain. Even when it's dry, Joshua Falkner knows how to make it rain.
Getting about 1.4 inches in 30 minutes, so that's a pretty serious thunderstorm.
Moving across this hayfield in Bridport, it looks like a giant marshmallow, or maybe a sugar cube. In truth, it's a rainfall simulator, a new tool to help Falkner understand our changing climate.
We have a large scaffolding with a sprinkler system on it that's very accurately calibrated to be a specific size storm event. We'll collect soil samples and water samples. The water samples will analyze for phosphorus runoff, for nitrogen runoff, and for sediment running off the plots as well.
The storm is contained within an approximately 43 square foot frame. As the water runs off, it's funneled into a bucket and collected for analysis. The simulator is being used to study nutrient runoff from hayfields. Two different methods of manure application were used here. One sprayed manure on top, while another injected the manure a couple inches into the soil.
We're hoping to see whether we get more or less runoff from the various treatments, and then we're also looking to see if we get more or less, primarily phosphorus in this instance. Nitrogen is important as well, but we're primarily looking at phosphorus because of the concerns with Lake Champlain.
This experiment is being conducted using different soil types and in different parts of the state. What Falkner has learned so far is to expect the unexpected.
One thing we're seeing here that was new to us today, especially on these clay soils in the summertime when it's really dry, even with a fairly large rainfall event, we're really not seeing that much runoff. We're not seeing what you would think you would see with that size of a storm, but that's still really good information. If soils are dry, this is a sod. Even if we have, manure on that ground, and we have a good storm in the summertime, we're probably not going to see that phosphorus leave the field.
Falkner is working together with Kirsten Workman, a UVM Extension agronomy specialist. This is a follow-up to a demonstration Workman and her colleagues in UVM Extension's crop, soil, and pasture team hosted here in 2018.
A few years ago, we were able to get funding from the Vermont Agency of Agriculture, Food and Markets to acquire and put to use a 40-foot wide Veenhouse manure injector. So this piece of equipment is special because it's designed specifically to inject liquid dairy manure into grass and legume hay fields as opposed to, say, in a cornfield. Part two, we were then able to get a second round of funding, this time from the Natural Resource Conservation Service. They have this great program called the Conservation Innovation Grant Projects. We wanted to assess how much of a reduction in runoff we get from injecting manure versus putting it on the surface of a hayfield.
Falkner's research is based on how water moves across and through soil, and what nutrients are picked up along the way, and how those nutrients impact the environment. Workman studies cropping systems and advises farmers on the best management practices to suit their needs and protect natural resources. So having an experiment that simulates a heavy downpour on a field where manure's been applied and figuring out what happens afterward is a win-win for UVM Extension, farmers, in Vermont.
Oh, it's perfect. it seems like we might have not conflicting, but like unrelated goals, right? As the climate change coordinator, Josh was constantly kind of looking at runoff and rainfall and how our fields deal with these extreme weather events. And so we're creating an extreme weather event today. But really, at the end, and I've said this a lot lately, that conservation farming practices are just good farming practices. And so what we're finding is the same practices that are good for water quality are the same practices that are good for climate change and soil health. They're also the same practices that are good for the farmer's bottom line.
I bring a piece of the puzzle around soil and water movement, but she's really just such a great link to the farmers, and she has the agronomic understanding and works with these conservation practices, and then I can bring my piece to the table, and it's just a really nice synergy.
Anytime we do the kind of research that Joshua's doing on real life farmed fields, that's like a really great opportunity, because then we know that it's really true on the ground, right? It's not just a little plot here or somewhere off far away or a model, right? It's like we can say to our farmers and to other folks in Vermont that no, this is how it works right here, using our soils, our crops, our manure, our weather, all of those things. And so the farmers, appreciate that more, and I think it just gives it, for me, a little more validity to say, no, it's really on the ground here.
Like rain, this research requires certain conditions. The result is improved environmental protections and better farming practices. Joshua Falkner, UVM Extension's Farming and Climate Change Coordinator, has come off the field and is joining us. Good to see you, Joshua.
Good to see you, Keith. Good to be with you.
Thanks. It's been a few weeks since we shot this story. Where's the research at?
Sure. So right now we are planning to, we're working with a farmer up in Franklin County in the Lake Carmi watershed. And some of your viewers may know there are some concerns with nutrient runoff in that watershed as well. And we're planning to do this same experiment up there in the northern portion of of Vermont. And we're also looking forward to doing this and planning to do this in the fall after that last hay harvest of the year, when manure goes on, going into the winter, and knowing that that is potentially maybe one of the riskiest times of the year, because soils are typically wetter and potentially saturated. So we have a few more rounds of this in the works for this year.
Joshua, this experiment depends so much on timing. You mentioned first cut. I'm sure plenty of our viewers know what first cut is, but tell us what first cut is and why these parameters and this timing is so important.
Yeah, so first cut is just simply the first hay harvest of the year. And it's often a really important harvest for the farm. It occurs in May, and it is often the highest yielding harvest of the year. So if a farmer has that first cut under their belt, we go into the summer, we have droughty conditions, poor growing conditions, and they don't get much in their second or possible third cut. They still have that feed going into the winter time for their cattle. And it is often a cut in which manure is applied immediately after that hay cut, because they want to get those nutrients in the manure back into the soil to help potentially fuel that hay regrowth for a second or third cut. And given that manure application is occurring, if we do have sea rainfall, there is of course risk of nutrient runoff. So it's a really good window for us to do this work.
Well, you mentioned rainfall, and rainfall has been hard to come by in Vermont this summer. What impact does this lack of rain have on your research?
Sure. Yeah, that's very true. It's been really dry out there. And there are certainly downsides for the farm in terms of crop growth. But for us, it's been really interesting and just understanding that there are potential upsides to this from an environmental perspective when we do have dry conditions. Soils are dry, and when we have rainfall, that a lot of that rainfall soaks in and doesn't run off, so that we don't have the potential for the phosphorus to run off of the field.
Joshua, we've got a couple of minutes left. The simulation we saw in the video was supposed to be a once in every 25-year event. Should we expect to see storms like this more frequently, 10, 5 years even?
You know, all bets are off with climate change. There's a lot of uncertainty, but that's certainly the trend, that the storms are occurring more and more frequent, heavy storms. I don't know that we'll see this size storm every 5 years in our lifetime, but I'm not going to put any money on that one, Keith.
I know how much you like it when I ask you predictive questions, Joshua. All this research is in an effort to meet standards for the TMDL, or total maximum daily load. What effect can best management practices have on the amount of phosphorus that ends up in Lake Champlain?
Yeah, best management practices are really, I think, the best tool in the toolbox for the state. They are the tool that farmers can use, and they're really the best tool that the state can use to address these phosphorus concerns. But it's also important to remember that the issues with the lake didn't occur overnight, and we're not going to fix these issues overnight. It's going to take a lot of hard work for many years.
It's important to note that changing farm practices is only one way to reduce runoff. What should those of us who aren't farmers do to help mitigate this problem?
Great question. In so many words, I say slow the flow. You know, if you have have areas on your property that are impervious or bare soils, mulch those bare soils. Try to improve the soil health on your lawn. Capture the runoff coming off your roof in a rain barrel. And there's lots of good resources for that through UVM Extension and the Lake Champlain Sea Grant.
Well, Joshua, thank you very much for joining me and for being out in the field. To find out more about Joshua's work on climate change, visit UVM Extension's Center for Sustainable Agriculture's website and follow the links to farming and climate change. I want to thank everyone here at WCX for making this program possible, and as always, thank you for stopping by Across the Fence.